This is going to be a review for the types of problems of Wednesday's DeltaMath assignment. Let's get right into it. All right, so already we see that we've got this table and we've got 4 different options: exponential, linear, quadratic, or not a function. So what we're gonna have to do is we're gonna have to make sure we look at one of each example so we know how to find which one is which. So here we've got, and to do this, I'm gonna be doing a little bit of math in my head so I know which example it's gonna be, but I'll go over the ones that we all go over. So here we've got, what do we need? We need to find a linear example. We need to find an exponential example. We need to find a quadratic example. And we need to find a non-function. That spelling was hard. Let me try that again. Non-function. All right. Okay, so we've got this first table, and honestly, looking at this, like, you wouldn't necessarily know what it is. I'm looking at this, and I'm fairly certain this is going to be quadratic, but let me see if I can convince you. So let me copy down the table first. X, f of x. Let me use my Oakland Public Library card to draw a straight line. One, 2, 3, 4, 5. 5, 12, 21, 32, 45. Okay, so if we want to figure out what something is, the first thing we should do is see if we can find a pattern between the terms, or between the y values. So here, to get from 5 to 12, we know that's plus 7. 12 to 21 is plus 9. 21 to 32 is plus 11. And 32 to 45 is plus 13. Now, if you're not sure on that mental math, that's fine. Go grab a calculator or use the calculator in DeltaMath specifically and check that, right? So if I go to DeltaMath and I do 45 minus 32, I get 13, which is the same thing as, here, let me do it this way. If I do 32, right, 32 plus 13, I get to 45, right? Okay, so what this tells me right here, immediately, the fact that these numbers are different, this tells me that it's definitely not linear, right? If for something to be linear, they all have to be, that addition needs to be the same all the way through. But if you have done the Wednesday activity, you might already notice a pattern here where if we think about how these numbers are changing, right? 7 and 9 are only 2 apart. 9 and 11 are only 2 apart. And 11 and 13 are also only 2 apart. This pattern, the fact that these numbers are a kind of consistent distance apart from each other, this is a good thing. This tells us that the values here are quadratic. Since these are all plus 2, this is quadratic. And just to be specific, it doesn't have to be +2. As long as it's plus a number, we're good. So, quadratic. Submit answer. Yes. Green check mark. Feels good. All right, next problem. Okay, so again, I'm looking at this, doing a little bit of mental math, thinking about how we're going to talk about this, and I'm pretty sure this is not a function. Here is how I know that. And if you're following along at home, see if you can figure it out before I say it. Can you figure out why this is not a function? What do you have to pay attention to be able to do that? All right, in this case, the first x value is 1. The second x value is 1, 3, 4, and 5. And then 30, 20, 12, 6, and 2. Okay, did you catch it? Did you see the thing that made this not a function? The thing that made this not a function has nothing to do with differences or finding patterns or anything. This is not a function because of these two entries right here. We have the same x with different outputs. You can think of this as like y if you want. You have the same x when x is 1. Y has to be simultaneously 2 and 6. This is no good. And so when that happens, so same x has multiple y's, we know it's not going to be a function. That's it. But notice, to do this, you have to pay attention to the x's, right? Looking at the y's doesn't help you the same way it did for the quadratics. You have to notice that the 1 shows up twice, but that the numbers across from the 1 are different. You have to notice that to figure out that this is not going to be a function. All right, so not a function. Submit answer. Yes. Green check mark. Feels good. All right, next problem. Okay, this is going to be a parabola. I'm not, or a quadratic. If you don't believe me, do the math. You can figure out the differences and then the second differences. But I'm not going to go through the details on that, just so we can do more. This is ooh, my mental math is not going well. I think this is a parabola as well. 7, 9, 11. Yeah, this is a parabola as well. And just to tell you what I'm doing, I'm counting the differences. So this is +5, +7, +9, and +11. Do you hear the 5, 7, 9, 11 pattern? So I know that that pattern is going to be quadratic. But I would really like to find one that's not a parabola. This is a parabola too. I know it's a parabola because it goes up and then it goes down. Give me something that's not a parabola. Next problem. Thank you. All right. So this one is not a parabola. This one is a function. And this one is going to be a linear function. And let me show you how I know. Now, if you think you know what I'm going to say, great. If you want to see if you can figure out why this is linear on your own or how I'm going to show you You should pause the video if you're watching the video and see if you can figure this out before I say it. 4, 5, -4, -6, -10, oops, -8. I missed one. -10, -12. Okay, if you paused, welcome back. So to figure out how we know this is linear, we have to think about what is being added or subtracted each time. So to get from -4 to -6, I would need to subtract 2. To get from -6 to -8, I would have to subtract 2. -8 to -10, I'd have to subtract 2. -10 to -12, I would have to subtract 2. What do you notice? They're all the same. So since these are the same, we say that this is constant change. Right? Constant change. And maybe we should be more specific. In this case, it's subtraction. It could be addition. So the constant change is more specifically addition or subtraction change. So constant addition or subtraction each time. And that's what makes it linear. Linear. Yes. Green check mark. Feels good. All right. So now we are hunting for an exponential example. This is going to be linear. And I know that because I'm counting the differences, +2, +2, +2, +2. Okay. So this one is not linear. It is not quadratic. And it is a function. Oh, it's not a function. Look. Oh, I didn't notice that right away. It's not a function. Do you see the 4s? 4 and 4 with 2 different numbers here. This is not a function. Ooh, I almost got tricked. Not a function. Haha, green check marks. That was a bonus problem for you guys who are sticking with it. This is another parabola, or another quadratic, sorry. Man, these exponentials are not showing up. Hey, okay, all right, I think I got one. All right, so this is going to be exponential. And again, if you can, I would say pause the video and see if you can figure out why this is exponential or how you would explain it before I do. 8, 4, 2, 1.5. Okay, so if you pause the video, welcome back. All right, so the pattern here, to get from 8 to 4, you could do addition, and if you did, it wouldn't be the same. Instead, you'd have to notice that to get from 8 to 4, you are dividing by 2, or you can also think of this as multiplying by 1/2, right? Oops, let me scroll this. To go from 4 to 2, you are again dividing by 2, which is the same thing as multiplying by 1/2, and etc., etc. To turn a 2 into a 1, you're dividing by 2, or multiplying by 1/2. And to get from a 1 to a 0.5, you're dividing by 2, or you're multiplying by 1/2. And it's this pattern here that makes it exponential. This is constant division or multiplication change. Right, so linear was linear because it was constant subtraction in this example. This is exponential because it's constant division, or it could be constant multiplication, right? So that's your exponential example. Green check mark, feels good. So those are the 4 examples for the types of problems you're expected to see for this last day of DeltaMath. I hope that was helpful for you. and have a great time working on this. And if I don't see you again, have a great spring break. Bye, everybody.